Hello and welcome back. We're looking at activity 30.1 and we're going to be going through questions number 6 through 9. I just wanted to kind of give you a heads up that I know we're doing pretty much almost every question in this section. Because this is the first section activity, we're going to go kind of hard on it, and then as the activity goes on, we'll do less in the other sections. Unless you need to do more, and you can, but I just wanted to make sure everybody was good as you went through the section so we didn't miss anything. Okay, so that being said, 6 through 9, hopefully you work through them. A couple things you need to keep in mind, or if you were stuck, that I can give you a hint before we work through what's on the board. You need to know your special right triangles, so 30, 60, 90s, know how they work. 45, 45, 90. Then you also need to know your Pythagorean triples, so 3, 4, 5, 5, 12, 13, things like that. They will continue to pop up the rest of this course. They will pop up in pre-cal, they will pop up in calculus, so you need to learn them. All right, that being said, let's go ahead and look at the problems we had. Yeah, we're going to start with number 6. Number 6 is a composite figure. Reminder, composite figure is when you take several two-dimensional shapes and you put them together. And so what we have here is a parallelogram and a rectangle. And they did that on purpose to make you think parallelogram, but I'll give you a hint. The magic here is actually in the fact that you have a rectangle and two triangles, all right? So notice we have the rectangle here. That's pretty straightforward. They're asking us for the area, so 5 times 6. We're going to get 30 for this value. So that's pretty straightforward. We're okay with it. The magic here is the fact that if this is 5, this has to be 5. So we get a 5 here. And then this is a right triangle. So we could do Pythagorean theorem to find this missing length. This is where I mentioned the Pythagorean triples. If you notice the 3 here and the 5 here, this is going to be 4. This is 25 squared minus 9. 25 minus 9 gets you 16. Square root of 16 is 4. So this length is 4. Now how does that help us? That is actually the magic right there. Because that's 4, we can deal with just this triangle by itself. 1/2 of this times this, which is going to tell me that this area is 6 and this area is 6, and I can add them together so that my parallelogram has an area of 12, my rectangle has an area of 30, and so my overall area is a total of 42. All right. Now if we're looking for units, it's going to be 42. Oh, bad teacher, wrong page. Sorry. 42 feet squared. Okay, because I know we got yard later on in this, but feet squared. Now, they want us to find the cost of this, so I had the A there, I erased the A and I put the 42. And so it's 42 feet squared times $8.50 per foot. Okay, so 42 times 850, that's going to give me $357. Okay, and that's how much this tabletop is going to cost. Hopefully that makes sense. Hopefully you got that and everything's good there. Okay, let's go to number 7, yeah? Number 7 is another composite figure. This one's a little more straightforward, a couple of rectangles. Where you divide this doesn't matter. I kind of like to cut it into 2 this way, okay? And the magic is you need to notice that this is 4.5 and this is 7.5. That means that we have 4.5 up here and we have 3 over here, which means 3 times 9, we get 27 for this part. And then 4.5 squared is actually 20.25. And then we would add those together, so the area would be 47.25. Hopefully you got that and you're good with that. Let's talk about 8. This is another Pythagorean triple. Okay. They tell us the diagonal is 13. They tell us one side is 12. That means this missing length right here, you're going to do 13 squared minus 12 squared, and then take the square root. 169 minus 144 is 25, and the square root of 25 is 5. Again, another Pythagorean triple. If you can notice that right away, it saves you the time and you can move on, okay? And you want more time. You want your mind to be fresh as you go through these problems. So the faster you do them, the fresher you'll be. Okay, so area, 12 times 5. Hopefully we're okay with that. That's going to be 60. And then the perimeter is 12 and 12 and 5 and 5. So 24 and 10, we get 34. Okay, so area of 60 and perimeter of 34. And this one was in centimeters, so we can put 60 cm squared here and 34 cm. For perimeter, keep in mind perimeter is one-dimensional, whereas area is 2. Okay, number 9. Number 9 is probably my favorite problem in this particular section because it brings in special right triangles. Notice that 60-degree angle there. They want you to notice that. What does that mean to you? Why does that matter? How does that help you? Let's change color so you can see it. Well, because it's a 30, 60, 90, I know that I'm always going to have this relationship. This length is going to be half of this length, whatever it is. I don't know what it is, doesn't matter, but it's always going to be half of it. And then this length is going to be that times the square root of 3, okay? So let's talk about what we have. We know that this length is 4. That means 2x is 4. If 2x is 4, that means x is 2. If x is 2, that means the height of my parallelogram is 2 square root of 3. All right, that's going to give me my height. So they're asking me for perimeter. Let's kind of take this 2 parts. Perimeter is simply going to be 5.5 plus 4 plus 5.5 plus 4. Okay, so that's 9.5 times 2. That's going to be 19. That one's pretty straightforward. And we're looking at feet. So that's going to be 19 feet. Single dimension. The area is where we needed that 2 root 3. That's where this comes in. We're talking base times height. Our base is 5.5, so 5.5 times 2 root 3. Now, if we want an exact answer, okay, we're going to leave the square root of 3. 2 times 5.5 is simply going to be 11. So my exact answer for my area is 11 root 3 feet squared. And that would be what I'm looking for, okay? And I think that's the best answer for that particular question. Next parallelogram that we have is a 45, 45, 90 triangle. Notice this bottom corner. This angle is 45. And so what do we know about 45, 45, 90? Those are isosceles triangles. So this length has to equal this length, okay? And so we have this is x, this is x, this is going to be x root 2. Well, we know that length has to be 7. So what I do is I say, oh, x root 2 equals 7, and then I solve for x. When I solve for x, I get x equals 7 over the square root of 2. I do what's called rationalizing denominator because I don't like to have the square root of 2 on bottom. So what I do is I actually multiply by 1. So square root of 2 over square root of 2. Square root of 4 is what I get on bottom, which is actually just 2. So my answer for my x is going to be 7 root 2 over 2. And what is x? X is my height. So this is a 7 root 2 over 2 goes here. Okay? And so that's going to help me on my area. Let's talk perimeter first. That's the easy one. Perimeter, we got 14, 7, 14. And then this is going to be 7 over here as well. So 42 for perimeter. That one's pretty straightforward. Hopefully you got that right. For the area is going to be base times height. So it's going to be 14 times 7 root 2 over 2. All right. Now 14 divided by 2, I can go ahead and cancel that. 14 divided by 2 is going to get me down to a 7 there. And then 7 times 7, my final answer, best answer, is going to be 49 square root of 2. Okay, and that's the answer we're going to be looking for. Hopefully those make sense. I'm going to give you a little more practice to make sure we're totally good on rectangles and parallelograms before we move into triangles. So if you would, go to page 436 and do number questions number 10 through 15, okay? Another, say, 10 minutes or so, and then we'll come back again.